Hey, let's go ahead and check out some notes we would have got into in the classroom, and I'll just kind of cruise along here and have you guys pick up what I'm putting down. So our first one here, find the rate of change of each relationship. The rate of change is also called the slope. The change in y over the change in x. Sorry, my triangles are a little terrible there. Change in y over the change in x. There we go. So that's just delta y over delta x, the change of, and that's what we got going on right here. So real quick, the other thing we wanted to point out here is that we are looking at proportional relationships. Proportional relationships, one thing is they always go through 0, 0 on the graph, through the middle of the graph. I look on the other side, not so much proportional. These do not go through the middle. Not proportional. But over here we can see these are relationships we're going to compare, and they are proportional relationships. This one maybe is a little bit off, but that's supposed to be going through the middle or the origin of the graph. Real quick, for proportional relationships, I'm going to not bring that up, but bring this up, our Little Caesars pizza. So that's a great idea to think of proportional relationship because they're going up at a constant rate. If you buy one pizza, it's $5. Two is $10. Three, $15. And it keeps going up at that $5 every pizza. But the big thing is that it goes through 0, 0 on the graph, because if I buy 0 pizzas, I spend 0 money. Now, let's go ahead and compare these and looking for the change in y over the change in x. So over here, the change in y, this is going up or down, how much every time? Hopefully you're saying up by 2. And over here, the change in x is going up or down every time. Hopefully you're saying up by 5. And we see that the change in y over the change in x is 2/5. On the graph here, we'd go ahead and try our rise over run and go up. And be careful. Our units here go from 20 to 40. So that's a change of 20 on the y-axis. And this goes from 8 to 16 over here. Sorry if you can't see those numbers, kind of small there, but that is a change of 8. And 20 divided by 8 seems like it's going to be a much greater number than we got in the table. 2.5. So, and over here, that's something like 0.4, 2 divided by 5. So which one is greater? Hopefully you're saying that's this guy over here. Again, we could find our slope here, rise over run, or the change in y or the change in x. It's the same thing. And here this goes from 15 to 30 is a change of 15. And then from 2 to 4 is a change of 2, which this has a rate of change or a slope of 7.5. Over here, that's our slope or rate of change. Our slope always sits next to the x value. So our slope here would be 3. Which one is greater? It's this guy. So the other thing I wanted to go over real quick in this video is how to determine if there is a constant rate of change. So for that in a table, you just go ahead and divide down. Divide down, divide down. If you get the same answer every time, then you're good. So over here, 2 divided by 3, 0.6668, scary. 6 divided by 9, 0.6668, scary. 12 divided by 18, 0.6666. So yes, this relationship is proportional. Over here, last couple, they want us to determine the rate of change. I guess we'll finish out with this guy. This guy is going up by 2 on my x, and on my y, it's going down by 3. So my slope or rate of change would be -3/2 or -1.5. Today in your task, your quizzes, you'll be identifying tables that are proportional. So you'll be utilizing mostly this skill here, where I'd really recommend grabbing a calculator, and that'll expedite the process there. All right, thanks for tuning in, guys.